Hello, this is a video tutorial on how to run ANOVA or Analysis of Variance in PHSTAT. Now supposing this is the research question. Is there a significant difference in the serum cholesterol of the respondents when they are grouped according to marital status? And use alpha or level of significance equal to 0.05. Now why are we going to use ANOVA and not the t-test? Remember that the t-test can only be used if we want to compare the sample means from two independent samples. And since the marital status in this set of data is categorized into four groups, we have S for single respondents, M for married respondents, D for divorce, and W for widow respondents. Thus, there are already four independent groups, so we have to use ANOVA or Analysis of Variance. The other variable here is the serum cholesterol of the respondents. We have this data in this column. We start with the null hypothesis. We state the null hypothesis that there is no significant difference in the serum cholesterol of the respondents when they are grouped according to marital status. And the alternative hypothesis, on the other hand, is there is a significant difference in the serum cholesterol of the respondents when they are grouped according to marital status. So first is, we must separate the serum cholesterol of the four independent groups by unstacking the data. Again, we start with add-ins, choose PHSTAT, and then data preparation and unstack the data. For the grouping variable cell range, we are going to highlight the marital status column. And for the stack data cell range, we are going to highlight the serum cholesterol value, since that is again the other variable that is required in the study. So we click OK, and then we have to check this box also, since we included or we also highlighted the labels in the value or in each column. So we click OK. So we have now four independent groups: M for married, S for single, W for widow, and D for divorce. Now we're going to run the ANOVA test. So go to PHSTAT, choose multiple sample test, and then choose one-way ANOVA. The level of significance is 0.05, and then under the group data cell range, you highlight all the values. So by highlighting all the four columns, including all the values under each column, then we click this box, and then we click also this box. This is the type of post hoc test that is used in PHSTAT, the 2K Kramer procedure. Then we click OK. Now, we also click this because we're going to supply the Q statistics or the critical value in the post hoc test if the ANOVA results tells us that there is a significant difference among the sample means. So we click OK. So before we run the 2K Kramer post hoc test, we must check first the ANOVA results. So here are the four groups and the sample size. Count or the sample size. There are 53 respondents for the married group, 22 for the single group, 9 for the widow, and 16 for the divorce group. Well, these are the sum of the serum cholesterol values. Average refers to the sample mean also. We have 215 for the first, 210 for the second group, which is the single group, 236.89 for the widow group, and 207.31 for the divorce group. Well, these are the variances of the four groups. Now, these are now the ANOVA summary table. And we're going to look at, if we're going to use the p-value method, the p-value method is, the p-value is equal to 0.0058. we're going to compare this to the level of significance used, which is 0.05, and it is less than. So which tells us that when the p-value is less than the level of significance, the decision of the test is to reject the null hypothesis. So which means that there is a significant difference among the sample means. Now if we're going to use the F statistic, here is the value 4.4295, and we are going to compare this to the critical value. The critical value is 2.6994, where again F is greater than the critical value. Again, the test tells us to reject the null hypothesis. So since the ANOVA test results tells us that there is a significant difference among the means, we have to determine which of the means are significantly different, okay, or which of the pair of means are significantly different. So we now click the 2K Kramer sheet, and then we have to supply the value here, or the critical value, so that by comparing group 1 to group 2, it will tell us if the means are different or not. So to find the critical value, which we are going to place under the Q statistic column, then we are going to get the critical value from the Q or the Kramer 2K Kramer critical value table. So we're going to use this. You just search in Google for 2K Kramer critical value, and then choose this table, Q table for 2Ks. Okay, so this is now the table where the value for number of treatments is 4, while for the degrees of freedom in the denominator is 96, which we are going to use the first column. Notice that there are two values in every box. The values on the top are the critical values when alpha is equal to 0.05, while the values at the bottom are the critical values or the Q statistic when we are going to use 0.01 for alpha. And since we are going to use, or we use 0.05, so we are going to take the critical value that is found on top. That is the intersection between 4 and then 96. Now, however, 96 is not found in the first column. It is 60 and 120. Where again, we have, if you're going to check the values, the Q statistics when the degrees of freedom in the denominator is 60 is 3.74, while for 120 is 3.68. Now, since 96 is close to 120, then we're going to, as compared to 60, we're going to choose 3.68. So we're going to encode this value, that's 3.68, in our Q statistic. So we're going to encode it here. So 3.68. Now here are the results. Okay, comparing group 1 and group 2. Group 1 refers to the married respondents, and group 2 refers to the single respondents. The result tells us that the means are not different. So comparing the sample mean 215 and 210, there's a difference of 5. The observed difference tells us that it is not significantly different. Okay, the difference observed is due to chance only. Now, comparing group 1 and group 3. So, group 1 is the group of married respondents, and group 3 is the group of widow respondents. So, we have 215.49 for the mean cholesterol, serum cholesterol for the married respondents, and the mean serum cholesterol for the widow respondents is 236.8889. The observed difference, as shows here, is significantly different. So meaning we can conclude that the serum cholesterol of widows are greater than the serum cholesterol of married respondents. Next, we have for group 1 and group 4, the result tells us that the means are not different. Now, for group 2 and group 3, group of single respondents and group of widow respondents. So, it tells us that the means are different. So, group 2 and group 3, 210 and 236. We can say, therefore, that the serum cholesterol of widows are greater than the serum cholesterols of single respondents, because the result tells us that the means are the two sample means are significantly different. Between group 2 and 4, the means are not different. Between group 3 and 4, so widow and divorce, the means are significantly different. So we have 236.8889 and then 297.3125. So since the sample means are significantly different, then we can say that the serum cholesterol of widows are greater than the serum cholesterol of divorced. So this is how, again, we interpret the results of ANOVA, including its post hoc test results. Now, if, supposing, the results of the test tells us that there is no significant difference or do not reject the null hypothesis, then we don't need to proceed to the 2K Kramer test. Okay, so there is no need to conduct the post hoc test because the ANOVA, in the case where the test tells us that there is no significant difference among the sample means. So this ends my tutorial. Thank you.